Hi everyone, I'm Shirley and this video is going to form part of the About Cambridge series. So we are in November, which means it's nearing the time where some of you guys will be holding your long-awaited Cambridge interview. This is a very important stage of your application process to the University of Cambridge because it will essentially be the last jump that will determine whether or not you will get an offer from the University of Cambridge. As I mentioned previously in my How to Get into Cambridge video, I managed to remember and document some of the questions that I was asked in my interview, and also write down some of the thoughts I had about the question, as in my thought process, and how I went about answering the question. So in this video, what I want to do with you guys is really go over those interview questions, so you get a sense of some of the real interview questions you could possibly be asked during your interview, and also just so you can know how to go about answering and thinking about those questions. As you guys may or may not know from my previous videos, I am a Natsky, which means I study natural sciences. I'm currently in my third year and I have chosen to specialize in chemistry. This video will obviously be a chemistry-based interview, which means it might not be as helpful for someone who has applied to study English or ASNAC or theology, for example, but you can still watch the video just to get a sense of how academic this interview really is and what types of questions you might be asked. You know, you can kind of extrapolate the information from this video and make it more applicable to your own subject. This video is going to be split into 3 parts. Part 1 is just going to be giving an overview of the Cambridge interview, so the differences maybe between different colleges, and in part 2 I'll be talking about interview preparation that you can do to just make yourself feel a bit more prepared. And in part 3, we are going to be actually going over my real interview questions, which I have documented on this piece of paper, and just tips on how to start thinking about answering the questions and how to communicate your ideas. We are now in the first section of the video, where we'll be going over the sort of interview process, what to expect, how different colleges work, etc, etc. So, etc. Is it etc or etc? If you have made an application, you have likely applied to a specific college or made an open application, which means at this stage you should know what college is going to be interviewing you. Depending on what college your interview is going to be held at, the process is going to be slightly different. You might have a combination of interviews and entrance exams, or you might just have a combination of different interviews. I applied to Corpus Christi College, which meant that I had 2 separate interviews. I had one interview based on the subject I was applying for, and another compulsory maths interview, seeing as I was applying for natural sciences. So for those of you who don't know, natural sciences is basically a course which combines different types of sciences, and you don't specialize until you are in your 3rd year. There are 2 main branches of natural sciences. There is Bio-Natsky, which is biological natural sciences, and Phys-Natsky, which are physical natural science subjects. When applying, I was asked whether I was a Bio-Natsky or a Phys-Natsky, and I applied to be a Phys-Natsky, not being as interested in the biological subjects. I was then asked to specify whether I was a Chem-Natsky or a Physics-Natsky, and I was definitely not applying for physics. I didn't do A2 physics, I stopped at AS, so I specified Chem-Natsky. So this meant that I was going to have 1 chemistry-based interview and 1 maths-based interview. In your letter inviting you to an interview, you should be specified what college you have applied for and who is going to be interviewing you. So the university kindly provides accommodation for those who need it the day before or maybe the day after their interview. You can expect to have accommodation provided. I think you need to get in contact with the college to arrange this for you. When you turn up, you'll have people upon arrival who will just maybe show you where to go, calm you down a little bit, bring you to an environment where there are people just like you applying for a place at Cambridge, having their interview, just as nervous, just as excited. And so you'll really be introduced to a calm environment, not aimed at making you any more nervous, but just aimed at making you feel comfortable and making you feel welcomed. Now on on to part 2 of this video, which is all about how to prepare for your Cambridge interview. If you went to the type of school that sent you to different places to prepare you for this Cambridge interview, you might have come across people who made you feel as though their preparation was more intense, more productive, and better than yours. You know, you get the people who ask you, oh, have you read, how many articles have you read up on? Have you done this? Have you done an extra project? Have you done extra experiments? Do you want to hear about my stuff? Do you want to hear about my projects? Do you want to hear about my experiment? Do you want to hear about my preparation? And this can often lead to you feeling as though you won't get your place at Cambridge because you're competing against people who are talking about things you don't even know when you guys are studying the same subject. My advice would be to ignore these people and just stay in your own lane, focus on your own preparation, and do it your way with the help and support of your teachers. The main preparation that I would say you needed for a Cambridge interview is to obviously really be clear on your entire A-level syllabus. So the people who are interviewing you know that you're an A-level student, they know what you're being taught, and this is mainly what they're going to be questioning you on. Obviously, there are going to come stages where they're going to stretch you beyond the A-level syllabus to see how you can absorb information and use it and make it applicable to the things you already know. Having said that, the basis of your knowledge has to be the A-level curriculum. So my advice would really be to brush up on all the things you've learned throughout your AS and A2 so far. Really get that down on lock before you start worrying about extra projects, extra reading, and so on and so forth. I'm not sure about things like theology where extra reading might be more beneficial. I don't really know. But definitely for science subjects, be very clear on your A-level syllabus and the things that you know already. The beauty about interviews rather than tests, which is why I applied for a college which is going to interview me only and not make me sit an entrance exam, is that you have the opportunity to communicate the things you have and have not yet learned at school. So this interview is not a test of how much has your school taught you this far in comparison to other schools. This interview is really aimed at how much do you know about your subject, how passionate are you about your subject, and how can I stretch you to learn and absorb new information and use that to answer questions you've never heard before. Another cheeky tip I could give you to prepare for your interview is to look up the person who's going to be interviewing you. You are currently an A-level student, and what you might not realize is that science subjects are so broad. And when you get up to higher level education, what happens is you start focusing on a very specific aspect of that course. So right now, chemistry may seem like drawing a few mechanisms, as well as knowing a few metal colours off by heart, as well as knowing a few metal oxidation states, stuff like that. But when you get up to uni level and beyond, what happens is you become a very specific organic chemist, or you become a very specific inorganic chemist that only focuses on metal complexes, for example. So the person who's interviewed you has really surpassed this stage already. They are already specialized. They already have a preference for a specific aspect of the subject you are applying to. And I think this really tends to shine through in the types of questions they ask you. So the person who interviewed me, or one of the people who interviewed me, was an organic chemist. And I think this really showed through the kind of questions that I was asked. Had I been interviewed mainly by someone who was a physical chemist, I'm sure the style of my interview questions would have showed his preference for physical chemistry. So I'm not saying take this wholeheartedly. Google your interviewer and only focus on the part of chemistry that he or she is interested in. What I'm saying is be prepared for the style of questions to reflect their preference. So still prepare, you know, still become familiar with your entire A-level syllabus, but just be prepared that there might be a preference for organic style questions or inorganic style questions based on what your interviewer is specialized in. Okay, so we are now on part 3 of the video, which is where we get onto my real interview questions. So you guys can use this as an opportunity as a mock interview if you like, or you could just use it to listen to the questions you're asked and the thought processes I had. You know, you can pause and answer the questions for yourself, or you can just watch continuously, depending on what you really are using this video for. Before actually questioning and answering myself, I will just say that throughout the interview, I think it's very important to show your thought process. For some of these questions, you might not know the answer off by heart straight away. And this is not the end of the interview. You know, it's not a test of can you say the answer to the question within 0.5 seconds. That's not the point of the interview. The interviewer might end up being your supervisor, which means they're more interested in knowing, can this person learn from my teaching? Can the person adapt to the way I'm stretching him? Can he use new information that I'm giving him to answer questions in combination with the information he or she already knows? I think even if you don't know the answer, start explaining what you're thinking, what ideas you're thinking, what information you think might be relevant to answering this question. And they might just throw a little seed in there, you know, to help you, I don't know, blossom your plant, whatever analogy I can use there. Question number 1. Write down the formula for methane. My answer to this was wrong initially. This is the most simple question someone who studies chemistry can be asked, to write down the formula of the simplest alkane. And I got it wrong. I wrote down CH3. Everyone knows methane has a formula CH4. I wrote this down probably out of nervousness and probably because you can become very used to writing CH4, CH3, 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 blah 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 something, continuing your alkyl chain. So in my head I was just like, easy, CH3, I've written this down so many times. And you would think this is the end of my interview, you know, it's like asking someone applying for maths what's 1 + 1 and they're writing 3. But the interviewer just simply said, would you take a look at that again and you might want to change your answer? And I looked at it and I was like, oh God. In my head I said a little bit of a bad word, you know what I'm saying? But I just changed my answer and said, oh sorry, I meant CH4. And she was like, okay, that's fine. And that was the end of the question. So question number 2. Draw it in 3D. And when she asked me this question, I was immediately like, what? This is Cambridge. Now I'm in Cambridge, aren't I? Like, draw it in 3D. Like, are you mad in that? I was just thinking, there's no, like, I can't even draw. How am I meant to draw 3D on a 2D paper? But I calmed myself down. I took a second and I said, oh, she probably means geometries. You know, like we've been learning, tetrahedral, octahedral, square planar, trigonal planar, whatever. If you're studying A-level, you should know the 3D representation of a methane molecule is a tetrahedral shape. So you've probably drawn this shape many, many times before, so it's just easy, you know, using dotted and wedged bonds, and there is your answer. The next question was, what is the bond angle? So again, this is just straight out of the A-level syllabus. This is one of those things that you just remember. Tetrahedral molecules have bond angles of 109.5. Question number 4. Write down the equation to show methane burning in oxygen. So again, this is just another question straight out of the A-level syllabus. So you get methane plus oxygen making carbon dioxide and water. And then you can go back and balance out the equation by noticing that methane has 4 hydrogen molecules and water only has 2. So you need a 2 in front of the water, so you have 4 hydrogens going to 4 hydrogens, and then consequently balance out the number of oxygens that you therefore must have used. So then you get methane plus 2 moles of oxygen makes 1 mole of carbon dioxide and 2 moles of water. I was then asked, what is the oxidation state of carbon in each case? So for this, again, if you're studying A-level chemistry, you have probably learnt how to work out oxidation states of different molecules. So I was asked for the oxidation state of carbon in each case. I noticed there were 2 molecules which contained carbon, which was the initial methane and the product carbon dioxide. So you know that hydrogen has an oxidation state of +1 in every molecule. So if we have CH4, we have +1, +1, +1, +1, and then to balance out and make a neutral molecule, you need -4 oxidation state on the carbon. In the case of carbon dioxide, we know that oxygen has an oxidation state of -2 in every molecule except for hydrogen peroxide, where it has an oxidation state of -1. So if we have 2 oxygen molecules, we get -2, -2 together makes -4. So to balance that out and make a neutral molecule, we need a +4 oxidation state on the carbon. Question number 6. So for this question, I was asked to look at the formula that I'd written down previously for methane burning completely in oxygen. And I was asked to look at the difference between the oxidation states, -4 and +4. And I saw that there was a big jump of 8. And I was asked, does this look reasonable to jump from an oxidation state of -4 all the way up to +4 in a single step? And I had no idea, but I thought she must be asking me for a reason, so I just said, I guess not, it's a big jump. And she said, right, there actually are 3 intermediates between the 2 molecules, which have an oxidation state of -2, 0, and +2 respectively. So do you think you might be able to deduce the molecules of the intermediate steps? So I thought, oh, rah. If you give me a molecule, I know how to tell the oxidation state, but I don't know how to make up a molecule out of thin air. Like, I don't know where to start. So I said, could you repeat that? And she kindly repeated the question. And I said, right, okay. So, like, what exactly do you mean? And she said, okay, so there are 3 molecules that come in between, and the carbon in each molecule has an oxidation state of -2, 0, and +2, respectively. So is there a way that you could think of molecules where carbon has the oxidation state -2, 0, and +2? And then I probed further and asked, so I could use like atoms like carbons and hydrogens and oxygens? As I said, yes, exactly that. So then I went ahead and I'm just going to show the answer now. I guess the way you can just think about it is, what atoms can I add to a molecule so that the atoms together, without the carbon, make an oxidation state of +2, 0 and -2 respectively, so that carbon has -2, 0 and +2 respectively, if that made sense. So you can see that if we go from methane to methanol, we have a -2 oxidation state on the carbon. If we then go to formaldehyde, we have a 0 on the carbon, and then to methanoic acid, we have a +2 on the carbon. I hope you can see how carbon has these oxidation states. I know it might be hard out of thin air to make up these molecules, but I think if you go through it in your head, you can convince yourself that there is a way to put atoms together so that carbon has these corresponding oxidation states. For question 7, I was asked to name the functional groups of each of these molecules. So again, this is pretty standard A-level stuff. If you see an OH group, you know it's an alcohol. If you see a double bond O, you know it's an aldehyde or a ketone. In this case, we don't have any R groups attached to the carbonyl carbon, so we have 2 hydrogens attached, so we know it must be an aldehyde and not a ketone. For the last one, we notice a double bond O and an OH. So whenever we see these groups, we know it's a carboxylic acid group. So question number 8, which is the most acidic molecule and why? And for this I was like, rah. We've learned about pH. I know like acid, alkali. But we've never really learned about how to look at a molecule and say, that one there is so acidic. Yes. But I thought about it because I wanted to be able to at least give an answer. And I named them all again in my head and I was like, carboxylic acid has the word acid in it. So I said carboxylic acid. And she said, yeah, that's right. Why? And I said, well, it's called carboxylic acid. And she kind of giggled and she said, okay, so why do you think this might be the most acidic other than obviously implicit by the name? And I started to think and I thought, okay, I don't actually know the answer, but let me communicate what information I think might be relevant and hopefully it will lead me on to the answer. So I started saying, okay, we know that acidity is related to the concentration of H pluses, you know, floating around. So I thought, okay, so I said the more H plus we have, the more acidic something would be. And you know, they were nodding in encouragement to help me keep going on this train of thought. So I thought, okay, so in the case of carboxylic acid, if we want a hydrogen or a proton to fall off, we would want the bond to the proton to be weak so that it can just, you know, break and fall off, essentially. So I started saying that the oxygen is very electronegative, which means it draws electron density towards itself. So then we end up with a delta negative charge on the oxygen and a delta positive charge on the hydrogen. And eventually the OH bond would be broken, which means the hydrogen is easily released. And if we compare this to every other molecule, we see that the amount of electron density drawn away from the hydrogen is greatest in the case of carboxylic acid, which means the proton would fall off easiest in this case. So therefore we would expect the carboxylic acid to be the most acidic. Question number 9, draw ammonia. So ammonia is the sort of little tricky one, which only has 3 atoms attached to the nitrogen, so you might expect to have more of a triangular shape looking thing. But we know that there is a lone pair on the nitrogen. So you've probably learnt this straight out of A-level. We know ammonia has a tetrahedral geometry. So we just draw it just like we drew methane before, except instead of having a 4th bond to the top, we just have a lone pair lobe. Okay, I was then asked for the bond angle in ammonia, and this again is straight out of A-level. You know tetrahedral geometry has bond angles of 109.5. However, when we have a lone pair, this bond angle reduces by 2.5 degrees. So we have 109.5 minus 2.5, which is 107 degrees in ammonia. Question number 10. Could you give me the average bond length in a bond? And I was like, taken aback once again, you know, like, bond lengths, I know how to draw bonds, like draw lines. I don't know how long they actually are. And I just took a minute to myself because I was so determined to have something to say about every question they asked me, even if I didn't know the answer. I wanted to give them information that I might know that helped me answer the question. So I dig deep, and I cracked. I eventually said, I'm so sorry, but there is no information that I could think of that helped me answer this question. And the other interviewer said, well, you know, think about it. Sorry, this is how he speaks. Think about it. Do you think they might be centimeters long? Millimeters long? And I was like, I'm not dumb, like, I can't see a bond length. I know they're not on a centimeter or millimeter scale, you know? And then I thought to myself, and I thought about the lesson we had about benzene rings and the proof that benzene is a conjugated system and not just a series of alternating single and double bonds. And consequently, through studying this evidence for benzene, I had learnt the bond lengths in benzene off by heart, and I knew at the time that they were about 1 point something ppm. At the time, I didn't know what PM actually stood for. I just knew the bond lengths in benzene were 1 something PM, and I was like, actually, I actually know the bond lengths in benzene off by heart. They're 1 point da 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 PM. So I would say an average bond length would be around that same scale. And the interviewer was like, yep, yeah, that's right, PM, so picometers, that is 10 to the minus 12. And I was just like, that's good. I had no idea PM stood for picometers. I had no idea it was 10 to the minus 12, but I was just like, Shirley, just agree and get yourself out of this question and on to the next one. And saying PM did the trick. That was fine and fair enough. So there are actually a few more questions, but this is actually taking an awful long time, and I feel like sharing 10 questions with you guys has hopefully given you some insight as to how academic the interview questions are and how to go about answering them and how to go about sharing your thought process with the interviewer, which again, I can't express how important this is. If you don't know the answer, don't just say nothing. say things that are related in some way to the question, because all they're going to do is probe you. You know, they want you to do well, they want you to answer the question, but they can't work with absolutely nothing. So there are obviously the questions from the maths-based interview, and there are about 3 more chemistry questions left. I'm going to leave it here for now, and if you guys thought this was super useful and you desperately want me to make a video on the maths-based interview questions and a continuation of the chemistry-based interview questions, just let me know, and hopefully my laziness won't stop me from making that video. But I hope that this video has really shown you something and hopefully made you a little bit less nervous about the interview, because as you can see, these interview questions really do reflect the A-level syllabus, and there is really a way that you can use all the information you've learned at A-level to answer these questions, you know. Granted, the questions I discussed with you guys were some of the easier questions I was given, but overall I would say the interview is not very hard, you know. I guess if you know a lot more content and you've participated in chemistry Olympiads, for example, you'll be stretched beyond the point I was stretched to. But that's okay too, you know. I hope you guys find yourselves less nervous and more excited about your interview. If you have any more questions, just let me know in the comments. And as I said, if you guys want me to make a video on the maths-based interview and the rest of the chemistry questions, just let me know, and fingers crossed I'll get to it before your interview. But for now, bye bye, and thank you very much for watching.